Hello beautiful people, Miss Beeching here. In this skill we're going to look at calculating probabilities, but for constraints that involve the words at least, at most, and not. If you're doing this skill and you haven't done skill 1.4, which is about the words at least, at most, and not, please go do that skill first because I'm not going to go through what these words mean. We're just going to apply them to some probabilities. So in the last skill we learned that calculating a probability is as easy, oh my goodness, is as easy as working out the number of outcomes for the event you're interested in and dividing it by the total number of outcomes. So let's just jump straight into a few examples. We're going to first do some for the words at least and at most, and then we'll do some examples for the words not, for the word not. Okay, example 1. A random number is drawn for bingo out of the numbers 1 to 80. Calculate the probability that at least a 63 is drawn. So let's start by looking at the number of outcomes for the event we're interested in. So the event of interest in this case is a number that's at least 63. Okay, and remember that at least includes that number. And we know from the problem that it goes from 1 to 80. Okay, so that means that we're going to need to go 80 take away 63 to see how many numbers are between 80 and 63. So that gives us 17. And to work out at least 63, we're also going to have to add one more to get 18 because 63 is included. And if you're having trouble thinking about why we add 1, think about if you said at least 7 with the numbers 1 to 10. If you count on your fingers, 7, 8, 9, 10, there's 4 outcomes that include 7. So even if you did 10 take away 7, you'd get 3. So you need to add 1 to include that number in the at least. Whoa, that was a bad idea. So we've got 18 outcomes that fit into this category. And then the total number of outcomes is 80 because it's the numbers 1 to 80. So our probability is going to be 18 out of 80. Or if we want to simplify it, we could say 9 out of 40. And if we want to get really fancy, we could quickly turn that into a percentage by dividing and timesing by 100. And so it's roughly 22.5%. Cool. All right, let's do the second example. In this one, in one group of kids, there are 5 7-year-olds, 6 8-year-olds, and 2 10-year-olds. Calculate the probability that a randomly chosen kid is at most 8 years old. So let's note down how many kids we've got of each age first. So we've got 5 kids who are 7 years old. We've got 6 kids who are 8 years old. And we've got 2 that are 10 years old. Cool. All right. Now let's think about our outcome of interest. So it's at most 8 years old. So that means anybody who is younger than 8 or including 8 years old. So that means that includes the 7-year-olds and the 8-year-olds. So there are 5 7-year-olds plus 6 8-year-olds. So there's 11 kids in total that are at most 8. And the total number of kids would be everyone. So 5 plus 6 plus 2, which gives us 13 kids in the group in total. So then the probability of one of the kids being at most 8, would be 11 out of 13. And again, we could quickly turn that into a percentage by dividing and timesing by 100 if we wanted to. Don't have to, but that's roughly 84.6% chance. Fabulous. Cool. All right, so that's how we do at least, at most. It's pretty much the same as applying the concepts from the previous skill. Gets a bit trickier when we get to the word not. Okay. And to work out problems involving not, we need to understand that the sum of all the probabilities, so if we add up all the probabilities in the sample space, we should get 100% or 1 if it's a decimal or fraction. There has to be a 100% chance of something happening. That's a good way to think about it. And we're going to use that to our advantage when we do some problems. So let's say we had a chance of pizza being delivered. And say the chance of it being on time is 0.3. Okay, 30% chance. And we want to calculate the probability of the pizza not being delivered on time. And here's where our little fact up here is going to come in really handy, because there's only two things that could happen. The pizza's on time or it's not on time. So if the chance of it being on time is 0.3 and it needs to add up to 1, we can just say, okay, well, 1 take away a 0.3 would be a 0.7 chance of the pizza not being on time. It's your only other possible outcome. That one's pretty straightforward. Let's try a slightly trickier one. All right, here's our last example. In class 9Z, the chance of a student using mainly a black pen is 1/3, and the chance of a student using mainly a blue pen is 0.2. And it says, calculate the probability a randomly chosen student doesn't use a black or a blue pen mainly. So let's state the facts from the problem first. So we know that there's, for a blue pen, there's a 1/3 chance of that happening. And the chance of someone mainly using a black pen is 0.2. Now here's a tricky part. One of these is expressed as a fraction and one of them is expressed as a decimal. So we've got a choice here. We could either turn the fraction into a decimal, and then we're just dealing with decimals, or we could turn the decimal into a fraction and just deal with that. Normally I would turn this fraction into a decimal, but because 1/3 creates a recurring decimal, it's a bit yucky to deal with. So we're going to go the other way, and we're going to turn 0.2 into a fraction. So that's the same as 2/10, which is also the same as 1/5. Cool, so now they're both fractions. Let's get back to what the problem was asking. So we want the probability of not these happening. And we know that the probabilities need to add up to 1. So if we want to work backwards from that, we could say, all right, well, it's going to be 1 take away the prob of a blue or black pen. So let's work out the prob of a blue or black pen. And we're going to do that by adding these two together. So this part would be 1/3 plus 1/5. And to add those two fractions together, we need to convert the denominators. So we're going to multiply both of these by 5. So we get 5/15. And we're going to multiply both of these by 3 to get 3/15. And so in total, we get an 8/15 chance that it is black or blue. Oh Lord, we're just going to pretend it says black. So that means the probability of neither of those, the probability of not that, is just 1 take away 8/15, which is going to give us 7/15 left over. Whoa, done, fabulous. Okay, if you have any questions, ask your teacher. Good luck with the skill, and I'll see you next time.